is the second video for this topic test, which is on units 4 and 5. A lot of the questions are coming from the January 2020 paper, but not exclusively. I've chosen questions to test my students' ability to cover both the unit 4 topic, which is energy, and unit 5, which is solids, liquids and gases, in their preparation towards the mocks, which will be in January, to get them to revise more than one. For this topic, you also probably need to be aware of the forces unit, because you can't get exam questions in year 11 which do not cover previous topics, because they're involved, they're integrated. Okay, so I showed you the formula sheet in the last video, and because the quality of the focus wasn't as good as I would have liked, I'm just skipping through these again so you can see if the handwriting is clearer. Okay, so there's the answers to question 2A to B, working out that the extra pressure due to 15.8 meters of water is about 160 kilopascals, to two significant figures because they've rounded it up. Add the 100 kilopascals of atmospheric pressure and the total comes to approximately 260. So you've shown that it's approximately 260. Okay, that's what you need to do. You need to deduce it. Show that means show that you can work out how to get the 260,000 and make sure your working out is clear. You don't put the numbers without putting the equation. So equation, numbers in, answer with units. Get into good habits now, and then the examiner will give you more marks in the summer. Now this bit I want to just go through again. So the weight of the ship is higher when it goes, if it's fully loaded, obviously the weight is increased, so the upthrust will not increase until, to the same amount immediately, unless it displaces more water. To do that, it's got to go in deeper, so it sinks more deeply, and that pressure difference will also increase because the height in the equation we just used up here creates a bigger pressure difference between the bottom of the ship and the surface of the sea. So that greater pressure difference is what creates the upthrust. Okay, so this then creates a greater upward force, which will then create a balance between the two forces. But until that happens, until it sinks, the upthrust will not be equal to the weight. That's why it initially moves downwards. Okay, so I then showed you the mark scheme. Still not as good as I would like, the focus, which is annoying. And I've restarted the machine, so it tells you how you get the marks. And finally, there's question 2. We went through question 6, which was about reducing heat transfer by conduction, convection and radiation. It's a 6-mark question qualitatively, so you've got to write it all in there. You can do it as bullet points, and the examiner is giving you marks for all of these bullet points. Hope that makes sense. Okay, just making sure the focus is as good as possible. It's really annoying when the focus doesn't go perfectly. Okay, anyway, we're going to keep going forward. So we got as far as question 6. Question 7 is then about investigating pressure, which is really Boyle's law. So the student uses this syringe, containing trapped air inside, to investigate pressure. It has a pressure gauge, so it looks like you can change the volume by pushing the piston in. Okay, now if you know pressure, the Boyle's law, so if you halve the volume, you'll double the pressure, as I explained that to my students. Diagram 2 shows the pressure gauge, and they want to see if you can read what the pressure gauge is. Note the units are in kilopascals, that they want you to read it in kilopascals means thousands of pascals. Okay, so we went through pressure before, so they want you to read the pressure gauge and write the answer in there. So it's 23, is it 23, 21, 22, 23, 24 kilopascals yeah? So it's 24 kilopascals. They're giving you units. You'll get 1 mark if you've read it carefully. Okay. So we did it in class with the Boyle's apparatus, and we kept increasing pressure and seeing what happened to the volume, which is Boyle's law, which states P1V1 must equal P2V2. This equation is given at the front of this sheet, which I showed you before. It's one of the few equations they will give you for this exam. The piston is pushed in, so the volume of the trapped air is halved, yeah? The temperature remains constant. Remember, so Boyle's law, for it to work, you can only have 2 variables. One, we say the independent variable is pressure, the dependent variable is volume, but that only works if you don't change the temperature. So it's telling you the temperature remains constant. The other thing that remains constant is the amount of air that you're dealing with. It hasn't changed inside, so you don't want the amount of air changing. Okay? Explain how the reading on the pressure gauge will change when the piston is pushed in. Well, if the piston is pushed in, if the volume goes down, yeah, by a factor of 2, then the pressure will increase by 2 times. Okay, because PV multiplied together must be a constant. Okay, now if you can explain that, these 3 lines, you will get the 3 marks. I'll show you the mark scheme afterwards so you can put it in the writing. You can't write it like this. You've got to write it out in words because they want you to explain it. But these are the concepts. If volume goes down 2 times, the pressure will increase 2 times. Why? Because pressure times volume must be a constant, or P1V1 must equal P2V2. Okay, so you've got to be able to explain this in words, but you can always reuse the equation to back up your thinking. Part C says the position of the piston is then fixed so that the volume of the trapped air in the syringe is now constant. So this time we're keeping the volume constant. The air in the syringe is then cooled, so the temperature will decrease. And the temperature, remember, we always have to use it scientifically in Kelvin because that is related to kinetic energy of the particles, and degrees centigrade does not tell us anything about the exact amount of kinetic energy. Okay, remember the temperature in Kelvin is directly proportional to the kinetic energy of the particles inside a gas. Okay, so you double the temperature in Kelvin, but it must be in Kelvin, then the kinetic energy of the particles will increase in line with that. Okay, state how the motion of the air particles inside the syringe changes when the air is cooled. So if the temperature goes down, yes, then the kinetic energy of the particles, so if T goes down, then kinetic energy of the particles, yeah, will decrease. And we'll have a look at C if that will get us the 1 mark in a minute. And then finally, the final part, again, is kinetic theory of gases. So all of this, the movement of particles, is called the kinetic theory, movement theory of the gas particles. Explain how the pressure of the trapped air increases explain how the pressure of the trapped air inside the syringe changes when the air is cooled. Okay, well, if the temperature goes down, yeah, the pressure law says if the temperature goes down, then the pressure will go down. They're in line. These are directly proportional. Okay, if one goes down, the other goes down. Unlike Boyle's law, when if one goes up, pressure goes up, the volume goes down. They're inversely proportional. These are directly proportional. So what happens if the temperature goes down, then the pressure goes up? But explain how. It wants you to say, well, how does the pressure go down? And that's because, so this is now the explain, because the kinetic energy of the particles decrease. And if the kinetic energy of the particles decrease, yeah, there'll be fewer collisions, for example, with the walls of the container per second. So they'll collide less frequently. So the frequency of collisions decreases. If you can get that point across, then you will get all the points. So then if that happens, the collisions also means less force per unit area of the walls. Because all the force on the walls are actually due to the microscopic collisions in the gas. So that's what causes air pressure, pressure in the tires of a car, for example. So let's have a look at whether we got all the marks or not. So in that final question, it says the speed or velocity or kinetic energy of the particles decreases. We got that point. And then it says the pressure decreases, the particles collide with the walls less often. So we know the pressure decreases due to the temperature. The particles collide less often, we got that. And the particle collisions is what determines the force. So if they collide less often, they'll collide with less force. Okay? Fewer collisions. So that's basically question 7 done in this paper. There's one more question. So again, I'm not happy with the quality of the focus. So yet again, I'm going to stop and do question 8, which is the last question I want to cover in this paper, which is on density. So when you're going through it, if you're my students, you can use this video to do your correction after you've done this test. This YouTube video will only become available after you've done your exam. Okay, so I'll come back and do question 8 in the next video. Don't forget to like and subscribe, etc. Share it with your friends, and see you in the next video. Apologies for the focus.